Can you see the screen?
Yes, sir.
So in the theory class, we are talking about the references in C++, and the basic points that we discussed about references. So these are some means of creating pseudonyms to existing storage units or existing storage entities. These may be pointers or constants. So you can create an additional name or a reference to existing pointer variable or to a existing constant that is already allocated some space, and as a result, when you create references, there is no additional space. Hello, any question? Hello. So there is no additional space that is allocated. There is some noise that is coming. So whoever he is, can you switch it off? Can you switch off your microphone? Somebody has switched it on. Can you switch it off, please? So the first thing is there is no space allocation, and we can create as many number of references as we wish. And another point is we cannot create aggregate references to aggregate of items. That is not possible. But if we would like to create a reference to a specific element of an array, one dimensional or two dimensional, that is possible. So we would like to assign a name to a particular, say maybe the ith element of the array. So those are possible, and because it is not associated with allocation, so dynamic allocation of references variables also does not make sense. And references, because these are names which we need to associate, so you cannot just leave a reference variable or reference name uninitiated. So initialization is must. And another important point is once you initialize, once you assign a particular name, a new name to some existing entity, that particular name cannot be reassigned or cannot be reused once again, at least within that scope or within that during the execution. And we are talking about the differences of reference and pointers. These also we found. Null, assigning null value to the reference, again it does not make sense. So in our last class we basically talked about the different passing different ways of passing reference parameter passing, and one of them was passing references to functions when we call them. So we talked about call by value, call by address, and call by reference. So what we found, when we need to call when we call by value, so we are basically copying the contents of this z here in zz. So here the z value is 10, so the value of 10 is actually copied because z contains the value 10. When we are calling by address, here I am specifying the ampersand z. So here the address of z is copied here. Say it may be 2080. If this is the location for z, this is the space for z, that is storing 0. So that is what it means. And if you are passing reference of z means we have to pass we have to declare a reference variable. In case of address, we have to declare a pointer variable. So here we are passing neither value nor address, but just a reference. Okay, so this means we are, so this same location will be identified. Earlier it was z, and this time it will also be identified as zz. So within this scope, this new name, this ZZ is valid. So ZZ is valid only within this scope, right? But the same entity here, if you would like to call it as Z, it will not respond. It will say it is out of scope. But here within this function, I mean, if we consider it to be the red one, so here within this, the name Z is valid. Okay, the name or ID Z is valid, and here the ID ZZ is valid. So here we can see a lot of similarity with the real life scenarios where the same person in a different context, he is completely recognized by a different name and he might play a different role, whatever. So depending on the, this red context, this name is Z. In the blue context, its name is ZZ. Okay. So you can say that references can create names in different scopes. We can create different names, different IDs in different scopes using reference. So here using reference, we can create different IDs or names in different scope. So this is one possible use of reference where you don't have to pass the address, you don't have to pass even the value, but because this Z is local, so the reference, so this name Z will not be valid in the function that you call, but you don't even want to allocate space of integer variable or a pointer variable within the function. There is no need. So you can do it by simply declaring a reference of that particular variable within the function local to it. So just you can use that name so that it can be used. Okay. So the advantage is we don't have to even create. So first thing is the Z, this is not global also. Z is still local. The contents of Z is still there, but the scope of Z is not here. So if you create a reference, you don't have to create additional space to hold its value or to hold its address. Without additional space, you can just create a name which is only valid in this scope, and you can do that. Got the point? Is that clear?
Yes, sir.
So this is one advantage, and another advantage, as you can see, what is the other advantage is the way you access or modify the contents. If you are passing address, you see, to modify the contents, you have to write asterisk Z parenthesis plus plus, but here it is just ZZ plus plus. So using reference, it is as same as like we increment using the variable name, but because it's a pointer, you have to use the indirection operator to get into that location, and you have to do that accordingly. So another advantage is if you use references, you can achieve the same thing. You can, if you want, within the function that you have called, you can update the contents, but the code, or it will look more compact and smart, right? Because there is no additional unnecessary use of indirections and all this. Okay. So one thing is, this is one point. Using reference, we can do this. Another point is updation of the variable within the called function becomes the syntax of updation becomes compact and easy to read and more readable. So no use of indirections, etc., or these arrows and all this. So these are advantages of but still you get the power of updating that part. So definitely another advantage is no additional storage to store the value or the address is required. No additional storage required. Okay, so now, so this is a code. So I have just removed it just to keep the focus on. So I have written this piece of code. So can you see this piece of code? Can you see this? Is there anything strange looking that you can see here in this piece of code? Is there anything strange that you can see? Is this correct? Forget about references. Can you see this? What it means? It's a function name which accepts z, or maybe say value whatever it is, 10.
So we're setting a value for it, sir. So we're setting a value for the function.
No, what we are doing, that is a different thing. But is there anything strange that I wrote here as per your whatever understanding till date? That is my question. Because I have given the, I have not hidden the outputs and all. That is fine. But can you see, I mean, is it something surprising?
So we are assigning value 5
Ampersand
to
before
the
function.
functions.
One again?
Ampersand before
No,
function.
assigning value for a function, that's not possible, kind of.
No, I mean, make it even more simpler. So function calls, if I have an assignment operator, so if I have an assignment operator, so in which side we generally call functions, we specify function calls?
The right hand side.
Right side.
So we have the L value and the R value, right? This is the R value and this is the L value. So which side generally we make function calls? L value or R value side?
R value.
R value. So till now fn or whatever you write, you write here. It may be void, it may be. So have you ever seen a function call appearing in this side? No matter what we write here. Have you ever seen this?
No, no, sir.
So this is a thing that you should have noted. So that is something strange, right?
Yes, sir.
So it doesn't matter what I do, what is the intention, forget about that. But for the first time when you look into it, you say that what is this? I mean, how can a function appear in this side? Your function returns. But what does it mean actually? So if you say that I would like to assign it to the function, but generally function, whatever it accepts as input arguments, it is just passed like this, right? So what is the meaning of this? Got my point?
Sir, we are overwriting the return value by the
Yes, again,
value.
I know that because I have shown you everything here. So what I have done, we can always argue and we can always clarify. But the point is that fine? So, but this is happening here, right? And this is correct. So that's the first thing. So how we utilize it and what is the meaning of it? What is the purpose of it? That's a different thing. So first of all, if this is accepted, so how this is possible? I mean, if I consider that, okay, if I compile it will work, so then what can be the purpose? So what a function, what if it returns, we can write it in the L value. Got my question? Actually I should not have shown you all these details, outputs and all, but yeah, I forgot to hide this, animate it. So what I should have returned, what a function should have returned, because inputs are anyway you are putting this input, that's fine. What a function should have returned, so that you can place a function call in the L value. That's the second question. So this is possible only if a function returns a reference kind of item, some items reference. Got the point? So this is possible
Sir, can't we modify it if it's not a reference kind of thing?
Can't we modify means?
Means can't we overwrite it like what we have done here?
No, again, I am not talking about the purpose. So the purpose can be achieved in other ways. I am talking about because it is not that you can always say that. So what it says, as you can see, that this G's, the value of G was 0. So within this, I have just made some changes in the G and I have mentioned it. So ultimately, what is done when I display after this the value of G, this shows here 5, right? So basically, through this function call, whatever I'm doing, I mean, I can do many things here inside also, but this return type is meant for modifying the contents of G, right? So you can say that, okay, why should I do so much of things? So I can do it here also. That's not a problem. You might say that, okay, instead of just writing 5, I can have another function call which might have returned something and that I can assign. So the point is, the first thing is only if it is possible only if the function returns a reference type. That's the first thing. A reference type. Okay. Again, I am trying to repeatedly tell you that don't try to decode why I am doing this. There are reasons when it is not an option, but you will be forced to do this. We'll come to that later on. Like returning references is not an option, it's not a choice, but there are cases where it is mandatory, compulsory. But this is, I'm trying to illustrate that if a function returns a reference, then we can use it. I mean, it may not be always need to be placed in the L value, but this is a case which is straightway an example of function returning reference. Are you getting my point?
Yes,
Hello?
sir.
All others
Yes.
till this point?
Yes, sir.
Okay.
Sir.
So here, if you, so as you can see here, this is a function prototype, and I have written here integer reference because I'm trying to assign that integer value. I mean integer literal into it. That's all, and it is accepting integer int zz. So whatever is the value of z, say for example z is here, it is 10. I'll be passing that. So that's not a problem. Now the point is, if a function wants to return an integer, if I have declared something like say x here, can I return here x? If I write here x, can I do that? Oh, it's a big problem here. Can I mention here x? Are you getting my question? Instead of g, could fn this particular function, can it return x, the reference of x?
No, sir.
What is the
No,
problem?
sir.
What is the problem?
X is local, sir.
X is local. So what happens? So whenever you are returning x, up to this it is fine, but whenever the control comes out of it, what happens? Is there any existence of this x?
No, sir.
No, sir.
So x, where it got allocated, this value of x, this storage of x, where from we got the allocation of x?
Stack, sir.
From the stack. So this is only containing the space for x when the function is active, right, in the stack segment. Once it is out of it, you say that I would like to return the reference of x, but the thing is that particular variable x or that storage does not exist at all. Got the point? So if you would like to, or if you require to return some reference of some variables, what kind of variables you can return? What kind of variables you can return?
Global, sir.
What kind of variables a function can return? Hello.
So global variable.
Any other variable apart from global? Anything else?
Sir, inherited like
Static.
Static, yes, good. Because static, once it is, you have declared static, will it go off as you call a function or as you exit from a function? Even if it is, say, even if you have declared a static local variable within a function, once the control comes out of the function, will the static allocation of that particular variable corresponding to that function, which is local, will go off?
No, sir, it will
No,
remain.
It will remain, but the thing is you cannot access it, that's all, right? So the idea is but the entity remains there. So if the entity remains there, you can still return its reference. But here the problem is this local non-static variable, the entity does not exist. So whose reference you are so you are trying to provide reference of somebody of some faculty who has already retired 2 years back. So that's not possible, right? So that's the problem. So the thing is, a function can return references if required. So this is one extreme example, which may not look very convincing as the way we are trying to use it, because the objective of whatever we have achieved could have been done in a much simpler way. So here what it says that the function's purpose is to set the value of whatever this global variable is to 5. That's all. So that would have done in a much simpler way. Now one way you can say that we can try to do this, say we can have, so first thing is, this is not possible. Okay, this is, okay, I cannot remove it also, anyway, leave it. So one possibility, but if it is a global variable, or if it is a, what's happening? So if it is a global variable, or if it is a global variable, or if it is a static variable, we can return the references. But for non-static or those things, we cannot do that. That's fine. But here what you could have done, say if you would have G and maybe H, two global variables. Now you can say maybe here, based on something, based on the value of ZZ. So if ZZ is divisible by 2, then you return H, else you return G. Got the point? So this you could have written within the function body here. Got my question? Got my point? What I am trying to explain?
Yes.
yes, sir.
So if it is the case, then it makes sense. Like earlier you said that, okay, always I will be trying to reset the value of G, but it says that within the function you do some bit of computation, and based on the computation you would like to, so there are several static variables or maybe global variables. So based on the outcome of the computation, you would like to reset either this global variable or the other global variable or this static variable, whatever you want. So that, then it makes sense probably. Okay, but if this happens, then the function will appear in the L value of the assignment operator. Okay, so this is fine. Now can you tell me, before I switch to the next, so can you tell me when returning of references by a function or by a method is essential? Those who have done C++ a lot, can you say when it is essential?
Sir, when we want to modify it in the main function again.
No, it will be a very straightforward answer. There is no ambiguity, nothing cryptic about it. So can you be very specific where exactly we would like to have. I mean, you cannot do it otherwise. Those who have done a bit of C++ coding or a lot of C++ coding, I'm asking them. Any idea? Have you ever used it? Okay, I think some of you told that, okay, we know references, but we have never used it. So let me give you the hint. We have talked about cascading, right? Hello? We have
Yes,
talked
sir.
about cascading. So one application can be, so let me write it in a different. So one application of this return by reference is cascading, cascaded calls, cascaded operator calls. See, if we would like to write something like this, say matrix M1, M2, M3, M4, whatever. So matrix is a user defined class. M1, M2, M3 are instances or objects of that class, right? So if I write cout M1, cout, I mean M1, M2, M3. Can I do this? Can I do this?
Yes, sir.
This seems to be achievable. Now, if you would like to achieve this, so first thing that you have to do is, so which operator we are overloading here? Which operator? This operator, right? So to implement it, to make it happen, this operator this overloaded operator or the operator function, that means operator, this function, this is a special function, operator function. So this function must be defined within the matrix class definition. Okay, others, those who cannot follow it, will be doing it in thorough details, so no need to worry about it. But if you can follow, it's fine. So what I mean to say is, operator this particular operator function, if we would like to have this implemented or have this working, we have to write this function, the body of this function, include it in the matrix class definition. But once we do this, now you see, so the thing is, this cout, this M1 will be first called, right? So it will be calling this one first. Okay, so once this is called, now the outcome, whatever it is required, it will display the matrix, but this operator function will be returning the same cout. What is the cout? Cout is the object, right? Cout is a predefined object. Is that fine? Hello, are you getting me?
Yes, sir.
Yes, sir.
Yes, sir.
So this cout should be returned by this. So this operator function will accept M1 as input, but it should return the reference of cout. So cout is a OStream object. So basically the OStream objects object reference of the OStream class should be returned. Now once it is returned, so once it is done, you will have the same cout here, right? The reference means the same cout will be here. So that cout, the same cout will now invoke this one. What the point? Then cout this M2. So it's again the same operator function call where M1, M2 will be passed, and once it is done inside whatever it is required, it will again return what? The same cout's reference, right? So again, after getting this executed, you will have again the cout returned by it, right? So cout. So that cout will call this M3. Are you getting me? So that will call
Yes, sir.
M3. So
Yes.
that is how, so that's a trick how this cascaded function call, cascaded operator function calls work, or cascading of operators, overloaded operators work. So here, if you don't know how to return references, what is the purpose of returning reference, probably things will not work. Again, you'd say that I can do this series of displays, that is fine, but if you'd like to have a cascaded say calling of these operators, of this particular operator in a single line, you cannot do it without knowing return by reference, or without using that feature of return by reference. Is that fine? Okay,
Yes, sir.
so we'll have it in details later on, but just to have the idea of why we are talking so much about references, because we really it's difficult to appreciate that why it is required. So the previous one, what we told, that instead of calling say a function by through call by value, call by address, from now on we will try to call a function through call by reference if possible. Another point which we found is if there is a cascaded set of operator calls, we have no other option other than calling or returning the reference of it. So this is another example. So now, as we discussed about the relation between reference and constants, let us explore pointers and constants. Let us explore the similarity, or how these two together work. So this is an integer variable d initialized. Now what does it mean? Dr is a reference created for d, right? And what we are trying to do here, what is the objective of these two? What is the first one? CDR1.
Sir, constant
CDR1. What is CDR1?
Sir, constant reference for D.
It's a once again, tell me what is CDR1?
Sir, constant reference for D, sir.
No, it's not a constant reference. See,
Reference for constant.
it's a reference to an integer constant. It's a reference, that's all. It's not a constant reference. See, constant reference, that is makes sense. Reference, can we talk about reference variables? Does it really make sense? Reference variable. Can a reference name or ID sometimes refer to this person, sometimes refer to that person? Is that possible?
No, sir.
So in true sense, there is no, so that it's a reference variable. We call it as a variable, but it is not in that sense it's a variable, because that variable or that reference tag cannot change its I mean cannot be associated with different storages at different times. That is not possible. So references by nature they are constant. You don't have to say that. So this is not a reference it's not a constant reference. Rather, it should be called as CDR1 is a reference. So by default it's constant, because the constantness we have already discussed about it. It's a reference. You can just say it's a reference referring to or reference to an integer constant. Got it? What is the difference between CDR2? CDR2, how do I read it? Also a reference to an
Variable.
no, it's not
Integer variable.
No, why it's an integer variable? There is a constant keyword here. So what we mentioned, that whether you write the const keyword here or here, both are the same. While talking about pointers, didn't I mention? If you mention the const keyword here, or if you mention it here, does it make any difference? Can you recall? Hello, can you recall this?
Yes, sir, it will make no
Yes,
difference. It's all the same.
So they're all the same, both are the same. Okay. But if I try to forcefully put a const keyword here, it says that, so this is because it's meaningless. So it says that const qualifiers cannot be applied to in this kind of reference type, because they are by default constant. So you cannot make any changes. There is no point of asking that it to be reference, it to be constant. They are by nature constant. Can you see the case here? Can you see this?
Yes, sir.
And then if this is not possible, so this is also not possible. So only these two are possible, which says that you can have a reference pointing to a normal variable like dr. Dr is a reference to a integer variable, but this CDR1 and CDR2, these are references to integer constants or constant integers. So if this is the case, then if you write plus CDR2 or if you write plus CDR1, it says that increment of read-only references. So the point is, you see this D is just a variable, right? So if you write plus D, this is very much possible. This is okay. This will be actually 21. D is 20. If you write plus D is 20 because D is a variable. But when you use this name or this reference of D, which is mentioned as CDR1 or CDR2, then you cannot make the changes. See, this is not possible. But if I write plus DR, then it will be 22. So got the difference? So D is an integer variable. This D is an integer variable. Through a reference DR, which is as it is declared, it is referring to an integer variable. You can make the changes. If you write plus DR, it will be incremented. But in these two cases, CDR1 and CDR2 will treat this reference variable, this reference will treat whatever they are referring to as constant. And because of that, if you try to increment plus CDR1 or plus CDR2, that will not be allowed, because this means increment of a read-only reference CDR. So because they are having, so these are references to read-only entities. They will treat the item that they are referring as read-only entities. Is that part fine?
Yes, sir.
So here, if I write, now see the other case. So if I have declared a constant integer, so integer constant, then if I would like to create a reference called say ER, which will be pointing to integer variables, not constants. So that is also not allowed. See, the item originally is a constant. Here the item originally is a variable. Now you create a reference which will treat that item as a constant. This is possible. But here the item originally is constant. And now you are trying to create a reference of that item, which will, and you ask it to consider it to be a variable, and that is contradicting, right? Got the point?
Sir, if we write constant ampersand here, will it accept?
Constant, yeah, that will definitely work. So that I have just mentioned afterwards. But the point is here, what I mean to say is the entity by nature is a constant. If you'd like to create just a reference and try to and you say that I just want to create a reference of that entity which will treat it as a non-constant, that is not going to happen. Got the point? So yes. The reference type is this, and you are trying to assign it to constant integer. This discards the qualifiers because they are, I mean, you are trying to violate the very nature of the item that you would like to refer, right? That is not possible. But here, if definitely this is a constant integer, and if you would like to write it, so originally is a constant, and the reference also treats it to be a constant here or here. So there is no problem in it in doing so. So the only thing is you can display the contents of E, that is 30, but in no way you can update either by writing E++ or by writing this or this. So this is not possible. Okay, because the item is itself a constant, and the reference that we have created for the item also treats the item as a constant. So this makes sense. And this is the last example. What it says, const in this. So if I write here if ampersand, so I create a reference to an integer and I just try to forcefully assign it to 90. One might think that okay, even if there is no existence of, so till this, so till now we are talking about references are initialized to existing storage units. Now I say that this f is, we are trying to create a reference of this value 90. So 90 does not mean any variable or constant which is not associated with some storage. So why we would like to write this with an expectation that if I do write this, then the compiler will force some allocation in the storage and will name that particular unit, storage unit, as f. the identifier as f. But this is not going to happen. Okay, but if I write here const, then this works. So what it says that in this case it will force this allocation in that storage, and but you cannot change that contents. Okay, so this is possible. If you display this, f will display the value 90. Got this point? Is that fine till this?
Yes, sir.
Yes, sir.
So simple things will work, the intuitive things will work, but non-intuitive things, if you try to force something, that will not work. Although this seems to be a bit strange. This part seems to be a bit strange, but still it is accepted. So let us just assume it. So we have already talked about it. The summary I'll write it later on before I send it to you. So the last one, the last topic of today's class will be the function pointers. Are you aware of function pointers? Do you know what function pointers are? How many of you used function pointers? Hello?
Yes, sir. Some of us are.
Have you used function pointer?
Not
Have you used? Hello? I'm not getting your voice. So you have used it, right?
Okay.
Yes or no? I am not. The voice is creating problem.
No, sir.
Sir, we haven't
Yes.
used it that much.
So function pointer. Say I have got a function, say sum int x into y, and I write here float, and I return x plus y, and I've got another function called sub int x into y, I return x minus y float, and I've got another function factorial int x int, or maybe it long. Okay, so how many functions I wrote here?
3.
3 functions, right? So here, if I would like to store the address of this function, this particular function, we are talking about function pointers. So what do I need to write? Address of this function. Tell me, anybody? Can you tell me? What should I write? I would like to declare a pointer, say function pointer fp. It's a pointer. First of all, it's a pointer variable which will be pointing to this function's address. So how should I write it? How should I declare it? Hello, try this. fp is a pointer, right? Now it's a pointer to this function. So how a function is characterized? How a function is characterized? No matter what we are doing here or here, doesn't matter. How a function is characterized? So it's
Return type.
no, not only return type. Function is characterized by characterized by its
So by definition.
hmm?
Definition.
By its
So function signature.
I have mentioned it here. By its
Prototype.
Prototype.
yes. What is the
Prototype.
function prototype here? What's the prototype of this function? What's the prototype? Prototype means what it accepts and what it returns. So what is the prototype of this function? Int comma int and returns int, right? That's the prototype. What is the prototype of this function? The sub, sorry, I mean this is float. So int and returns float. What is the prototype of sub?
Same, sir.
Same. But what is the prototype of fact?
Long and int.
Long and
Long and int. So when I say this is a function pointer, so function pointer pointing to this function. And how a function is characterized? Through its prototype. So somehow when in the declaration itself, I should be specifying what is the prototype of of that function, which it can point to, right? Is that fine?
Yes, sir.
So how to specify it? If I write here int, comma int, if I write here float, will it work? Will it work? What it is similar to? If somebody writes this and asks that, can you read this? What will you say? This is, it appears to be, this is a function name and this is the input type and this is the return type, right? So it's a so this whole thing is a function prototype. But I asked you to write a FP. I asked you to write FP as a function pointer, which is capable of pointing to a function of this prototype, right? So what should I write then? What should I write then? This is how I should write. Got my point?
yes, sir.
If I write this, that means this is a function pointer. This is a function pointer. This is a pointer variable. So FP is so forget about function. This is a pointer variable. Now as it is mentioned like this and this, so it's a pointer variable pointing to functions of this prototype, of this prototype. Got the point? So this is a declaration of that of a function pointer. So this is a function pointer. FP is a function pointer capable of storing the address of any function of this prototype. Is that
Sir,
okay?
if we have another function with the same prototype, how will the compiler differentiate?
I'll come to that later on. So I'm just coming it just now. So is this fine? Let us see that how a function pointer can be declared. A function pointer to be specifically which will be pointing to the address, or which will be capable of storing the address of this function sum. Is that okay? Is the declaration fine?
Yes, sir.
So if I would like to assign the address of sum, what should I write? If I would like to initialize it itself here, what do I write? What will I write here? This equals what is? So this means this is the address of this computes with the address of function sum. Now where this object code, this is a function, so it's the object code of sum, the binary of the function sum, where it is stored, which segment it is stored, in which segment these function bodies are stored. Tell me quickly, don't take so much of time.
Yeah.
These are hello.
Code segment.
Yes, good. Code segment. So this function pointer, earlier what we found, whenever you declare a pointer, sometimes it points to the heap segment, sometimes it points to the maybe the data segment also, because if you are storing the address of a static data, static variable, it will be. But here this is one instance where this pointer points to some location in the code segment, right? But which is actually read-only segment, because codes you cannot change. So your code cannot change itself. That is not possible. But this is what it means, right? So now this fp, it is just a function point. It's a function pointer variable. It's a function pointer variable. So if this is so can I write this also? Is this possible? It's a variable. It has pointed to sum here, but if I want, can it point to sub also at some point of time? Is it possible? Are we not getting things? Hello? Is it possible or not?
Yes, sir.
This is very much possible. It's a variable, it's pointing to this. That's all. But if I want, can I write this also?
No, sir.
This is not possible.
No,
No,
sir.
sir.
Why? Because the prototype does not match. So when you declare a particular function pointer, you just say that, because in the declaration itself, no matter what it will point, this itself also does not know what is going to happen, whom it should be pointing to, but it says that I am capable of pointing to any functions which accepts two integers and float. No matter what the function does, how big the functions are, doesn't really matter. So I just can point to that much. That's all.
Sir,
And
what
here,
about the arguments when you have initialized?
so arguments you have to, that need to be taken care of by you itself, because when you are passing this integer, maybe that you are passing the arguments in those. We will see that. I'll come to that. So first of all, this pointing this, it's possible. So fp can point to either sum or sub, because both are having the same prototype as the definition of fp goes, right? But it cannot point to fact. So now the next question is, if it was pointing to sum at this point, so if I would like to invoke sum, what do I need to do? If I write cout sum 5,3, then it works. So if I would like to do the same thing, invoking sum through this pointer, because the pointer now points to the sum, what should I write? What should be the syntax? Got the question? Using the indirection operator, you should be going to the contents, that means going to the code of sum, and then you should be passing 5,3. So these two are same. Got it?
Yes, sir.
So directly you are invoking the function, and through the function pointer you are invoking the function. So here you can do it like asterisk fp 5,3. So if I write cout, so what do you get here? What is out? What it displays here?
8.
8.
What it displays here?
2.
2. Now if I would like to create, definitely this fp, this function pointer fp will not be able to point to fact. So if I would like to have another function pointer, definitely I have to have I need another function pointer. If I would like to have some other, say fq, another function pointer which will be pointing to fact, how should I declare it?
Long asterisk fq int.
And then it can point to fact. And then if I want, so if I want, I can write cout 5. Is that okay?
Yes, sir.
Got it? So look into this code. What I did, so the same thing. This is sum, this is sub, this is sum, this is sub, this is fact. Now what I did here, you see, Okay, so before I get into this, so can I declare a function array of function pointers? Can I declare an array of function pointers?
Yes, sir.
How to do it? So say maybe if A is an array of function pointers which I would like to have the address in the 0th one, the address of sum, in the 1th the address of sub. What should I write? How to declare this? Got my question? All others got my question? I would like to declare say if maybe A as an array of function pointers. So what should I write? This will not work because it's a single pointer. I would like to have an array of function pointers. What should I write? Where should I give the array of 2 elements? What should I give? Got it? Got this?
Yes, sir.
So this is what I did. So here this fp2 is a fp is a function pointer array of size 2 which can point to any functions with prototype int, return type int, and prototype float int. So if I have done that, now what I have, there's a execute is another function, right? Execute, which accepts a single function pointer of this type, the same prototype. So here within say main, we have done this. So within main we have array of function pointers, and here I am having another function execute which is accepting a function pointer of this type. So it's a local variable fnp, local one. So here what I do, if fpu means the address of sum I am passing, this sub I am passing like this. So it gets executed here. Got the point?
Yes, sir.
So see the nice thing here that execute is so there is some kind of abstraction in execute, right? So execute is a function. There is some kind of abstraction that it is involved here. So execute doesn't matter. Sometimes it executes. So you see in this for loop you can do that. So you don't have to have in a single call. You can write execute with this pointer. You basically get the sum of the two values. Then with the other pointer you get the subtraction. The other two you get the multiplication, division, like that. Got the point? So execute is intelligent enough because depending on the pointer that you pass, it will act accordingly. So basically it was not only so the action that it takes, that is different. So it is not that within the execute there is a switch statement and that is the case. So it's basically it can choose which function to actually execute. Are you getting my point here? So when this function gets bound, so is it an example of static binding or runtime binding? Binding means whenever I call this, so which function body to call? Can it decide during the compile time? Can it be decided which body to bind? You know function binding? Hello? Do you know what function binding means? Whenever we make a call to a function corresponding to the position where in the code the function is there, you have to provide the address. So if I write here this, say within the main, if I write here fn or fx or say sum, so during the compilation what does, so if in the code segment it knows that the sum is in 6000, so it will just replace it as call or jump into the location 6000. In fn, say call or jump, the control jumps to 7080. So here, so the call to 9080 like this. But if you have got this execute like this, so can this, so execute is here, that's fine. So execute means it will say it's called to this list location, so it knows it will jump to this location. But here when it calls this one, can you really make a jump? Can you really decide, can the compiler decide during the compilation time that which particular function body it should jump? Because there is a function call here, because there is a function call here, can it really figure out where to jump during the compilation?
No, sir.
So is this not something strange that you can see from till now? Whenever you have made a function call, during the compiler itself, the compiler can decide where to jump whenever the function is called. But this is one case where you really cannot figure out where to jump. So this binding, so this is called binding of the function body to the function call. This is called function binding. So when this binding will take place, in this case, this is during, are you getting me? During
Runtime.
runtime or execution. So this is called runtime binding. So this is one instance of runtime binding, but this feature of runtime binding has been exploited in implementing virtual functions, polymorphism, and all this. I mean, those who are aware of C++, they know those terms, but might not be knowing that how that is implemented actually internally. So saw this difference. So this is an example of runtime function binding.
Sir, why it can't figure out during compile time?
Now, how can it figure out? You can see. So this is a function call, but can you really do you really know that? So it depends on what you are passing here. So what you are passing here, can you know this? I can say that okay, let it be always 0. I can make it always 0, and then compile. I can make it sometimes. So if it is u, so maybe I make it so the thing is, you see, it is u, but I write c out u. So sorry, c in u. Then what it means? So I say this u, but c in u. That means whatever, sometimes if you give 0, then after going here it will call this one. If it is 1, it will call this one. So can it be done in the compile time?
No, sir.
Got the point? So this is called runtime binding, and this is a very important concept which need to be explored later on in details. And these are some tools that is given to the, and that Strauss-True probably has thought of to create a lot of abstraction that we see these days. These days, everybody of you know, and many of you know Python, but Python is highly abstract language, too much of abstraction. You really don't need to have the size specified, the type specified. Everything seems to be very nice and compact. But a CS student, being a CS student, you should not be just happy in using those. You should be knowing that how this can be achieved, because maybe after another 5-10 years some other language will pop up, and the features, you'll be asked to write the features so that these are supported. Got my point? So these are nice tools that we can see, which will be used later on to provide the types of abstraction that we see in C++. Is that okay?
Yes,
sir.
sir.
Okay, so this topic I think we'll start in the next class. Pointers, references, structures, self-referential structures. Any questions till this point? But I don't see too many submissions. What is the problem? Are you not getting things, or the response is extremely poor? I think till date I have checked, only eight of you have submitted. Why it is happening so in a batch of 180, 190? Hello?
Sir, actually, the indentation program, sir, was a bit difficult to run, sir, because The file handling part we were not very comfortable with, like at least for my case, sir.
Okay, so what about others apart from that? There is no answer at all. See, if this goes in this form, so I'll also not put so much of effort because my portion is already done. So I'll hand it over to Obhijit or Deepanita. They will take care of the rest of the course, and I'll then again continue with that during those polymorphism, virtual function, and all this. It's not that, I mean, they will also teach, but the thing is, there is no point of going so much in details because anyway, if you would like to write a C++ code without knowing this also you can write. That is not a big deal. There is absolutely no response apart from 8 or 10 students. Even if you don't you cannot complete the file handling, what about the rest of the assignments? You could have uploaded excluding that, and later on once you do that, resubmit it. That's all within the deadline. Even for the assignments also, I'm trying to solve or give hints about the assignments. So it's almost half done. Hello, I'm talking to the class. There is no response. And
Yes,
out
sir.
of
We'll
say
submit, sir.
180 students, only 110, 120 students appear. The rest of the students, I don't see them in the class. I don't know what they are doing, what the problems are. So it becomes really difficult for me to figure out what is happening. Okay, decide because if this goes on like this, then it really demotivates me. And yeah, so whatever portion is there, I can finish it fast. That's not a big deal. Okay. Okay. Fine.
Hello, sir.
Hello.
Hello, sir. I had one question to ask in the linear congruence generator. Sir, what will be the limits for the chi square value?
Yes, so there is as such no limit, but it depends on the domain or the application that which is your acceptable
Yes,
range.
sir. The number of
Yeah.
iterations,
So it is just to,
what
so
we are
right
doing
now
that.
I don't impose any limits, any range, but it is just for you to see that maybe if you have generated a set of numbers, say 100 numbers. So when you have a narrow range, you generate small numbers and you keep increasing the size number of values that you generate, and see that how the chi-square value is changing. Another thing is having a larger range, increase the range but generate the same number of values and see that how the chi-square is. So you just have a feel that how what is the impact of increasing the range as well as increasing the number of values that you generate within a given range. So it was meant for that, but right now maybe there is no as such limit for that for acceptance. But in all other cases, when you are developing some applications, this makes sense. It says that beyond this range it is not acceptable. Got it?
Yes, sir. Sir,
I
and
just expect,
the
yeah,
rand
yeah.
and the rand function, sir, it does not take time as seed, as in such like it generates all every time like the same numbers, I guess.
How can it happen? Have you used srand?
Sir, min std underscore rand, that one you're saying?
Srand, where you set the
No, sir. I
seed
guess
for that. You just
oh,
explore
sir.
srand.
Okay, sir.
Hmm.
Hmm. Thank you.
Anything else? Any other questions? Any other questions?
No, sir.
No, sir.
There are no questions and there are no submissions. So what is this? So do you want me to write each and every assignments for you? That also I can do. So you just copy it, paste it, and submit it. That's all. That is also possible. Anyway, decide by the next class. so that I can figure out my plan, how to take the class. Okay, bye.
Thank you, sir.